Okay, so permutations with repetitions. So we did permutations where all the objects were distinguishable, right? So you could tell them all apart. We started off really by looking at arranging all the objects all the time, and that led to factorial notation. And then we looked at a subset of the objects, so maybe arranging 3 objects from a set of 5. And now we're going to look at repetition. So permutation is a distinguishable arrangement, right? So how many different or how many distinguishable arrangements can be made using the letters B-O-S-E or Bose. Okay, so how many are there? Have we figured out? You give it to me notation or number of them, or we're going to use all the letters. So 4 letters we arrange 4 factorial ways. Or 4p4, which is 24. And so here are the 24 ways. B-O-S-E, B-O-E-S, B-E-O-S, B-E-S-O, B-S-E-O, B-S-O-E, and so on, right? So there's 24 arrangements. I just want to save this. So what's going to happen if we change the E to an S? Okay, so what happens if we change E to S, right? So that should be doable, right? All in one swoop here. Go home, find replace E with S. And you notice I made 24 replacements. That kind of makes sense. I mean, there were 24 arrangements, which were all distinguishable. But how many distinguishable arrangements do we have? So we look and say, well, wait, no, those 2 are the same. And nope, these 2 are the same. And these 2 are the same. And those 2. Man. So how many do we have now? And if I can start pairing them up, then we're going to have how many arrangements? 12. Okay. So there will now be 12 distinguishable arrangements, right? So the 24 different arrangements became 12. So what fraction do we have of what we had to begin with? 1/2, right? And then what's another way? Okay, let's just make a note here. So if we change E to S, then there are 12 distinguishable arrangements, or 1/2 arrangements. Or half of what we had, what we started with. Now what's the reason, right? Well, the reason is we can't tell the S's apart, right? Now if we called this S sub 1 and this one S sub 2, then this arrangement would be S2 and S1. Right, and then we could tell them apart. So if they had little subscripts on them, so we could tell this was the first S that you originally started with, and then here's the second one. Now they're in a different order, but we can't, right? Because they're all S. So we have half. Now, what's going to happen if I change all the O's to S's? Okay, so we're going to change all the O's. Go in here, say replace, this time O with S. And notice made 24 replacements because there were 24 O's to begin with, right? Every arrangement had an O. Okay, now how many distinguishable arrangements? Wait, let's see. What if I got B? You got 3 S's and a B. I don't know. Okay, starts, well, I don't know. It's hard to say, right? So, whoops. Hey, cut it up. So this become B, all leading with a B and then ending with 3 S's. We got SB, SS. So let's just kind of underline the SB, SS's. There's one there. There's one there. There's one there. There's one there. Okay, so I've got what? 1, 2, 3, 4, 5, 6 of them. Can I tell any of those 6 apart? Okay, here, let's do a different color for the B, S, S, S. So we've got 1, 2, 3, 4, 5, 6 of those. And then what if we do S, S, B, S? 1, 2, 3, 4, 5, 6 of them. And let's do the same. So SSSB 2, 3. SSSB. Oh, right here. Okay, so how many distinguishable arrangements do I have? How many colors did I underline with? 4. Is anything not underlined? No. Then there are 4 distinguishable arrangements. And how many letters do I have repeating? 3. I got 3 S's. Okay, so let's look at this. If we change O, then we now have 4 distinguishable arrangements. And what fraction is that? 1/3. Well, we started with 24. So how many do we have? 24, we go down to 4. What fraction is that? 1/6. Okay, but how many letters are the same? 3. So how do we get a 3 into a 6? What do we do to 3? 3 factorial, right? So this is really 1 over 2 factorial, 1/2. This is 1 over 3 factorial, or 1/6, right? Because I want you to think about it as, well, really those S's, when I changed the E to S's, then we had 2 S's, right? Now how many ways can you arrange 2 S's? Well, 2 factorial ways, right? Like it'd be S1, S2, or S2, S1. How many ways can you arrange 3 S's? Well, you could think S1, S2, S3, or S1, S3, S2, or 3 objects. I'm arranging these 3 objects 3 factorial ways, but I can't tell them apart, right? So I can't tell any of these S's apart. So we have 1/6, right? So what we have to do is basically divide out the order. When there's repetition, we have to divide out the number of ways of arranging the repeating things, right? So here's how it works. We have 1 over 3 factorial is 1/6 of the original arrangements, right? Of the original 24. Okay, so here's how it works. The number of permutations of n objects. When we do repeating ones, we're going to take all the objects, right? So, we started with taking all the objects, and we went to taking a subset of the objects. If there's repetition, we're going back to all of the objects. So the number of permutations of n objects, where A are the same kind, A are the same of one kind, B the same of another kind, and C the same of a third kind, is, so we take n factorial, and that's just the way we arrange the n objects, right? And we say, well, two of them are the same, so I can't tell S1 from S2 or S2 from S1. So we divide by 2 factorial, or in this case, A factorial. And B of them are the same kind, so maybe there were like 3 B's, and I can't tell them apart. So B factorial. And C are a third kind, so C factorial. Right, and then that just continues. If there were four different objects that repeated, then we would divide by that as well, right? So what's the number of permutations? Okay, and remember, permutations is arrangement where the order matters. Okay, because tomorrow we'll get into combinations. So what is the number of permutations of the letters in the word mathematics? Okay, so number of arrangements of the number of permutations, right? Distinguishable arrangements, ones that we can tell apart, of the letters in the word mathematics. So first thing is you start off by counting how many letters are there in mathematics. Right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters. So you go, there are 11 factorial arrangements of 11 letters, right? But there's 2 m's, right? And I can't tell those m's apart. Okay? I can't tell if this is M1, M2, or M2, M1, right? So we have to divide out the number of ways those m's can be arranged. So that's divided by 2 factorial. That's for the m's. Now we have, what else repeats? What other letter do we have more than one of? So we get A, right? So what you want to do is just kind of start at the first letter, M, and just say, okay, so that, okay, there's 2 m's, so that repeats. Then go to A and say, oh, there's at least 2 A's. Okay, 1, 2, there are 2 A's. T, so that repeats there. Okay, H, no. E, no. I, no. Okay, so we've got M, A, and T repeating. So that works out to 11 factorial over 2 factorial, 2 factorial, 2 factorial, which is 4,989,600. Now 11 factorial itself would be a lot bigger than that, right? Because we know 10 factorial is like 3 million something, so 11 factorial is going to be 30 million, or higher than 30 million, right? But we can't tell the m's apart. We can't tell the a's apart. We can't tell the t's apart, so we divide out the objects which are alike. Okay, questions? So, what we're going to do now is just look at a question. So, how many arrangements of the word, of the letters, How many arrangements? And when I say arrangements, we mean distinguishable, right? I mean, you shouldn't need to be told that it's different arrangements or distinguishable. That just should be understood. We say how many arrangements. How many arrangements are there of the letters in the word puppies? If, or let's just put down a colon. We're going to arrange them, and we're going to start putting restrictions on, right? So we have the first restriction, which is, well, we know there's 3 repeating p's, right? So what if there are no restrictions? So A without restrictions. Now, when I say without restrictions, there are restrictions, right? We know that we have those 3 repeating letters. So we say, okay, puppies, we have 1, 2, 3, 4, 5, 6. There are 7 letters. So without restrictions, there are 7 letters. They can be arranged 7 factorial ways, but 3 of them are p's. I can't tell the 3 p's apart, which means that every 6th arrangement of that is going to be the same, right? Or it's going to look the same. And so that works out to 840. Now, what if each arrangement begins with a P? All right, so how do we do this? It has to begin with a P. So just think about those letters. Pretend they're on Scrabble tiles. Right? You got your little shelf in front of you. It's got P, U, P, P, I, E, S. What's the first thing you're going to do then? Take one of the tiles with what? P, and put it down. So really what this question becomes then is, how many arrangements are there of the letters U, P, P, I, E, S, right? So really you can just toss out the P. Doesn't matter. That P is gone. It's like I got, 7 friends lining up for the water fountain, but, Jill has to be first. Okay, then take Jill out of it, now I've got 6 people. How to arrange that? Take one of the P's out of it, and I've got how many letters? 6. How many ways can I arrange 6 letters? 6 factorial. But how many of them repeat? It's going to be 6 factorial divided by 2 factorial, which is 60? No. 360? Right, so now we're dealing with restrictions, right? It's got to begin with a P. All right, take a P. Take that out, right? What's left? Let's see, what if it begins with 2 P's? The first 2 letters are P. The first 2 letters. Okay, what do we do if the first 2 letters are P? Take them out, put them down on the board, wherever you're going to spell out the arrangements, right? And then say, okay, how many letters are left? 5, right? What are those letters? Well, we've got U, 5. So that's 5 factorial. Is there any repetition here? No, there's no repetition. There's no more repeating letters, so it'll just be 5 factorial or 120 ways, right? What if all the P's have to be together? So if you remember, we did that where oranges, we did oranges and all the vowels had to be together. Okay, O-A-E. So we're going to do this the same way, right? Well, we're going to say, okay, I've got my little Scrabble tiles. Here's all the P's, but they have to be together, so I'm going to put them on one big tile, right? But it moves as a piece. Okay, and then I got a U, I, E, and S. So how many objects do I have to arrange? 5, right? So we got 1, 2, 3, 4, 5. How many ways can 5 objects be arranged? 5 factorial or 5p5. Got 120 ways. But what about the p's? How many ways can the p's be arranged? How many distinguishable ways? Only one way, right? Okay. We can't tell them apart, right? So if there were little subscripts on them, like P1, P2, P3, then we could tell them apart, right? We got P1, P2, P3, P1, P3, P2, P2, etc. These 6 ways, right? So with oranges, we wanted the vowels together in order. OE, there's only one way to put the vowels together in order, or I just put the vowels have to be together, don't put a restriction, then you're arranging 3 objects, 3 different objects. Here, you're arranging 3 objects, but they're all the same. There's only one way to arrange them. What if the first letter is a P and the next one is not a P? Now you notice in B, we just said the first letter has to be a P, right? Each arrangement begins with the letter P. And then any letter can come next. Could be a U, could be another P, could be the third P, could be an I, could be an E, could be an S. Here the first 2 letters are P. Could the first 3 letters be P in this one? Yeah, it just says the first 2 have to be P. Okay, so now we're saying the first letter, only the first letter, right? Or the first letter is a P, the first letter is a P. And the second one is not a P. The next one is not a P. Okay, how are we going to treat that? Let's write out all the letters, right? It's not going to hurt to. So P, U, P, P, I, E, S. Okay, first letter is a P. How are we going to deal with that? Take out one of the P's. Does it matter which one? No, they're all the same. Okay, so that P's gone. So now how many letters do I have to choose from for my second letter? So could be U, can't be P, can't be P, could be I. So 1, 2, 3, 4. So for the second letter, we have 4 choices. First letter, second letter, and then all the arrangements. So this one is a P. Okay, so we have one choice, right? I mean, there's really only one. We're taking one of the P's out. We have 4 choices for the second letter, right? Because we know it's got to be a U, an I, an E, or an S. Okay, can't be a P. And then, so let's just take one of those out. Doesn't matter which one. How many letters are left? 1, 2, 3, 4, 5. How many of them are the same? Okay, so first letter is a P, one way, right? Just take one of the P's. Next letter is not a P, take one of the not a P, right? Which is U, I, E, or S. Then, okay, I've gotten rid of 2 letters, one of which is a P and one of which isn't. Leaves me with 5 letters, but we know 2 of those are P's, right? So we end up with 240. So when we're doing these arrangement questions, we have to read it pretty carefully, right? So it says the first 2 letters are P. What you want to ask yourself is, can the third letter be a P? And the answer is, yeah, they didn't say it couldn't be, right? So how would they say it couldn't be? Or the first letter is a P, this one here. Each arrangement begins with the letter P. Can I have 2 P's? Yeah, they didn't say it couldn't. This one could say begins with exactly one P. Right? So that's just another way to phrase this. First letter is a P, the second one isn't. Or we could say begins with exactly one P. Okay, well, puppies like these things. Puppies like sausages. So what are the number of arrangements? So find the number of arrangements of the letters in sausages. All right, and now we're going to put down some scenarios, right? We have to sit down and decide. All right, how are we going to handle this? So first scenario begins with two S's, right? Or the number of arrangements of the letters in 5 that begins with, let's do this, that begins with two S's. Okay, so do you think that it could begin with 3 S's? Is there anything that says it can't? No? How would we say it can't? Could say the third letter isn't an S. Could say begins with how many S's? So instead of saying 2, what could I say? How about exactly 2? Right? Means it can be 2, but the third letter can't be an S. So this one, there's no restriction, right? Just got to begin with 2 S's. All right, so let's write out the letters. So what am I going to do? Cross out 2 S's, right? Okay, fine. You're going. You're going, right? I need you guys. Okay, but I've used you. So how many letters are left? 6 letters. Okay. But is there any repetition? So how many letters repeat? The A. How many times does the A repeat? 2 times. So it's going to be 6 factorial divided by 2 factorial, right? Which would be 360 ways. Okay, so we deal with the condition, right? It says, well, it's got to begin with 2 S's. At which point you ask yourself, well, is that exactly 2 S's? No, it didn't say exactly 2 S's. Well, did it say the third letter's got to be, no, it didn't say anything about the third letter, right? It just said it's got to begin with 2 S's. All right, we're good. So B. Now we're going to say exactly 2 S's. How can we do this? Well, got a similar question, right? So it begins with exactly 2 S's, then what's the third letter? Or how many choices do I have for the third letter? Well, what could it be? Could be an A, U, could be another A, G, or E. There's 5 letters, but here's the problem, right? If the third letter is an A, right, then when I go to figure out, okay, what's left, so now I'm going to have, well, let's write out sausages again. S-A-U-S-A-G-E-S. Okay, so we take out 2 S's, right? They're gone. Okay, and we say, well, okay, you've got 1, 2, 3, 4, 5. Okay, can't be the third S. So I've got 1, 2, 3, 4, 5 letters that it could be. But there's a problem, right? If it's an A, then when I go to figure out the rest of these guys, right, I've got 1, 2, 3, 4, 5 letters. That's just 5 factorial. But what if it's not an A? Let's uncross that A. Now we know it can't be an S, but what if it's the E? Then what have I got left? 1, 2, 3, 4, 5 letters, but there's a problem, right? Because now 2 of them repeat. Okay, so then we've got to deal with two cases, right? The third letter is an A, the third letter is not an A. But there's another way we can handle this, right? If it begins with exactly two S's, then what doesn't it begin with? What can't it begin with? It begins with exactly two, then it can't begin with how many S's? Can't begin with three S's. Do you think we can figure out how many ways we begin with three S's? What would I do to figure out the number of ways that we can begin with three S's? Crossed off two of them. What are we going to do? Cross off three of them. All right, so we want to, remember, we want to get exactly two S's, right? Now, what's A? A is two S's, but really it could also include, this also includes what? So this begins with two S's, or how many S's? Or three. This begins with two or three S's. So if we figure out how many begin with exactly three, what do we do with those numbers? Divide's not a good one. We want to take them away, right? So if we know 360 begin with two or three S's. If we figure out how many begin with exactly three S's, then how do we get the ones that begin with exactly two S's? Subtract, right? We subtract it off. So if we find part A, we got part A, right? We already have part A. So if we find the number that begin with three S's, subtract it from begins with two or three S's, then we'll have the ones that begin with not three S's, not, right? Exactly two S's. So here's the scenario, right? It's either that or we do two cases. So sometimes finding a thing we don't want is an easier way to find what we do want. Because three S's is just what? Well, we've got 1, 2, 3, 4, 5 letters. Are there any repetitions? Yeah. A, how many of them? 2. Okay, 5 factorial divided by 2 factorial is 60. So there's 360 that begin with 2 or 3 S's. Of those 360, there are 60 of them that begin with 3 S's, right? So remember, we didn't figure out exactly 2 S's. This is the number, let's see if we can move this down. So let's figure out, so let's write this down. Let's figure out how many begin with 3 S's. Okay, so we did that. 5 factorial over 2 factorial is is 60. So how many begin with exactly 2 S's? 300, right? So 306. So okay, let's just put this down. Begins with 2 S's or 3 S's is 360. Okay, so that's part A. Begins with 2 S's, but it could begin with 3 S's. This begins with 3 S's. Is 60. So there are 300 that begin with, okay, so begins with exactly 2 S's. All right, so it begins with 2 or 3 S's, easy to figure out, right? Begins with 2 S's or 3, right? It's just remembering that part A, there's no restriction, so it could begin with 2, but it could also begin with 3. We just cross off 2 of the S's and take the arrangements from the remaining letters. There are 6 letters remaining. The 2 of them are A, gives us 360 arrangements. I want exactly 2 S's. Well, I take out 2 S's again, but now we've got to worry about the third letter. If it's an A, then there's no restriction on arranging the remaining 5 letters. But if it's not an A, then there's going to be repeating letters. So we would have to figure out 2 cases. Now we could do that, I mean, just for fun. What else do we have to do? Let's look at the 2 cases, right? Or look at 2 cases. So the 2 cases are case 1. And case 1 is that the third letter is an A. The third letter is A. Okay, so if you think about it, we've got an S, and we've got an S, right? There's really only one way to take those S's, right? It's not, you can't say, well, there's 2 S's to choose from, so I'm putting a 2 down there. It's just, you know, I can't tell the S's apart. Then I've got an A. Okay, and again, so we got to think about the A. Where did I write this down? Actually, you know what? Let's just cross them off. Third letter A. So here we got S, A, U, S, A, G, E, S. Okay, so I've got 2 S's and an A. And what's left, right? 1, 2, 3, 4, 5 letters. Okay. So remember now the third letter isn't an S, right? It's an A. So it's just 5 factorial ways, which is 120. And then case 2, the third letter isn't A. Okay, so S, A, U, S, A, G, E, S. Okay, so 2 S's are gone. Can't use the third letter as an S, so let's take out an E. Doesn't matter, right? It's either the E, the U, or the G. Okay, what's left? 1, 2, 3, 4, 5 letters. Is there any repeating there? Oh wait, we gotta say one more thing first. So that third letter, right, it's either a U, a G, or an E. So we do have 3 choices for the third letter. Okay, it's either U, a G, or an E. Okay, so 3 choices for third letter. Okay, and then what have we got left? 1, 2, 3, 4, 5. But 2 of those are the same, right? 2 A's. 5 factorial over 2 factorial is 60 times 3, that's 180. That's 300 ways. So you got your choice, right? You can do it this way. You don't want to do it this way, right? You'll never remember, oh yeah, there's this case, what if the third letter is, what if the third letter isn't? It's like the even and odd numbers, where we looked at how many even digits and how many odd digits can you make. And evens, you got to worry about, well, does it end in 0 or does it not end in 0, because we know it can't start in 0. And that gives us 2 cases. So this is the same sort of idea, right? Like just say, well, this begins with 2 or 3 S's. We've already figured it out. There's 360 of them. And then here are the ones that begin with exactly 3 S's. Okay, that wasn't hard, right? Just 5 letters left, but 2 of them repeat. Gives us 60. 360 minus 60 is 300. Much easier than doing this. Okay, much easier. So sometimes you want to compute something you don't want to find because it's easier to find something you do want to find. Okay, last thing we need to know. This thing called pathways. So pathways, just think about pathways as being driving around downtown. So downtown's set up in a grid, right? You got streets, which run whichever way the streets run. You got avenues that run, what, east-west. You got streets that run north-south. And you've got this grid. So pathways. So it could be a grid of streets. It could be actual pathways running through a park or something like that. It's easiest to do in a grid, though. So let's say I've got this grid. So here's a grid of streets, and I want to go from A to B. And if we think about our directions, we've got north, east, south, west. So if I'm going from A to B, now I don't want to backtrack either, right? I want to go from A to B, but I always need to get closer to B. So I can't just sort of like, oh, let's go down 3 blocks and we'll go up a block and then over, right? So it's like you live in that apartment building and you live at A, you work in B, and you want to figure, well, how many different ways are there that I can get to work, right? You know, I want to take a different route every day. And how long can I do that for? So the first thing we do is we just say, well, okay, how many blocks do I have to walk? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have to go 12 blocks, right? Well, what if I go this way? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What if I go down and across? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What if I go over 3? 1, 2, 3, and then down 2, 1, 2, right? So 3, 4, 5, and then over 3, 6, 7, 8, 9, 10, 11, 12. It's always 12, okay? So the easiest way to figure out how many blocks is just to count along the edge, right? Either go from left to right and then down, or go all the way down and then go left to right. So we need to cover, so you got to think of this as, I'm covering 12 blocks. And 12 blocks, well, that could be arranged 12 factorial ways, right? But in going the 12 blocks, this is east, and this is east, and this is east, and east, and east, and east, and east, and this is south. So every time I cover this, I have to go 1, 2, 3, 4, 5, 6, 7, 8 blocks east, and I have to go 4 blocks south. So if you want to think of a route, right, I can just give you the direction. Say go east, and 2, 3, 4, 6. So that's one route, right? I'm just giving you instruction. Go east, then east, then east, then east, then east, then east. And then go south, 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 south. And I could say, I want you to go east, and then south, and then 2 blocks east, and then south, another 2 blocks east, and then south. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4. So that'll get you there too, right? I want you to go east 2 blocks and south. I want you to go east 2 blocks and then south. So that's another arrangement. So think of it as, what we're doing is we're doing an arrangement of 12 letters, right? But how many of them are the same? How many E's do we have? Okay, so we take out the order of those, right? We can't tell them apart. And how many S's do we have? So these are the number of different, right? Like 12 factorial, be like 300 million. What's 12 factorial divided by 8 factorial, 4 factorial? Try working this out, right? Because there's a good chance you could make a mistake. And now's a good time to make that mistake. So remember factorials under your PRB, right? Number 4. Okay, I got a number. What's the magic number? Did you get that? How many of you did this? How many of you did this? So the big division bar there says you got to do the 12 factorial, and then you need to divide it by the product of 8 factorial times 4 factorial. You have to do this. If you do this, this is what your calculator does, right? It says take 12 factorial, divide it by 8 factorial, and then multiply it by 4 factorial. So congratulations, you got a number way bigger than that, right? Because that's what you do. That's where our order of operation says. Take this, divided by this, multiplied by this, right? It's implied multiplication because you've written two operations together. That's not what you want. You want 12 factorial divided by the product of. Okay, so another way you could do it to avoid, you could go 12 factorial divided by 8 factorial and then hit enter, and then go divided by 4 factorial. So either recognize, hey, I'm dividing by the product of these two, I need to put them in parentheses, or I'm going to take this divided by this, hit enter, and then divide by 4 factorial. Whatever works for you. Just don't do this. Wrong answer. 495, right? So if you live downtown, had to walk those 12 blocks to work, and if you worked 365 days a year, which you don't, so you might, that might last you like 2 years. You could have 2 years of walking to work if you worked about 250 days a year, right? So take away weekends and vacation and stuff like that, right? It's a 2 different route every day, 495 days. You take a different route to work. One more type of pathway problem. This one looks like this. Okay, so again, you live downtown. But now you work over in Kensington, and the only way to get there is to go over the bridge. Right? So you live downtown, you got a number of routes that you can take to get you to the bridge, then you got to go over the bridge. And then you've got a number of routes that you can take to get from the bridge to where you work. So what we're going to do is just work out each number separately and then figure out what we do with those two numbers, right? So we're going to take this bit here first and work that out. Okay, so you just say, got to go 1, 2, 3, 4, 5, 6, 7. Got to go 7 blocks, 4 of which are east, 3 of which are south. And we can work that out because we already have a calculator. It's 6 times 5, and then 6, 35. Okay, you can work it out on your calculator. Just double check, make sure it really is 35. Okay, everybody check. It is. I just did. And then, so basically you got 35 ways to get to the bridge. And then we have a number of ways here. So again, we just count 1, 2, 3, 4, 5. Okay, going 5 blocks. 1, 2, 3 of them are east. 2 of them are south. And that works out to 10. But check that, make sure that's 10. Don't want to be feeding you any falsehoods. Right? Okay, so how many ways are there to get from A to B? So you got to get from A to the bridge, and then you got to get from the bridge to B. So what do we do with these two numbers? Add them. Got 35 ways to get there, and then I've got 10 ways. Or I've got 35 ways to get to the bridge, and for every one of those 35 ways, I have 10 different routes from that point on. So is the answer 45, or 350? Easy multiple choice question. A, 45, B, 350. Okay, so who thinks it's 45? Who thinks it's 350? Okay, so like 5 of you are going to score a mark, 1 of you isn't, and the rest of you have just randomly guessed C or D, which are just some other numbers that look appealing, but. Okay, so you have 35 ways to get and then, and what does and do? And multiplies. What word adds? Or. Right? If we can do this or that, then we add those together. If we do this and then that, right? So for every one of those 35 roots, so just think, I have 10 choices, right? So root number 1, then there's 10 choices. Okay, so that's 10. Root number 2, and then I got 10 choices. Root number 3, and then I have 10. Okay, and that happens 35 times, right? So for the first route, once I get, which might just be going, let's go here, and then I have a choice of 10. Second route, here, and then I have a choice of 10. This, then I have a choice of 10. That, and then I have a choice of 10. Okay, so you multiply. So if you run into one of these, you better get it right. I will hunt you down wherever you are post-secondarily. Come in with a Nerf bat, find a class that you're in, and just walk in and say, really? And that sinusoidal question too, like you got them both. Right? It said 5 sine blah plus 8. It said, what's the maximum? You got that one wrong, and this one. And it's not even because you were away today. I'll remember who is here. I'll take note. So it works better in January because I can actually track people now. I don't. I just see them in the hall and I say, really? That sinusoidal one? Come on. The pathway one? We used to, in Applied 30, whatever course it is that came before this, Applied 30, we used to do a lot more complicated pathway problems. And there was a way to do them, which you don't need to know. Right? But it'd be a pathway. And just imagine that you're walking around downtown, but there's a park. And so there's no road going through the park, right? So that avenue ends here and then picks up over here 2 blocks later on the other side of the park. And these streets, there's 2 streets that come, they end here and then they pick up over, right? We've seen those, right? So it's like a hole. There's a hole in the grid. And you don't have to worry about that, right? That's a lot more complicated. But we don't do that, right? We just do this, and at most you're going to see this. And at most, that's fine. And at most you're going to see one like this, and you're going to say, okay. Just work out each one individually. What is it? It's a permutation with the repetition, right? A question like this first came up on a Math 30 exam. And it was like, here's this pathway, and how many ways are there, right? And it's like nobody knew, right? It was the very first time we taught Pure 30, and nobody was thinking, hey, it's just an arrangement of letters, right? Of the letters E, and we were, oh. Right, it's just an arrangement of the letters E, right? You got 4 E's and you got 3 S's, and that's 7 letters, but 4 are the same and 3 are the same, and followed by that. So once we knew that, then this type of question became really easy. So if you weren't here today and you are listening to this, congratulations, you have a shot at it. Otherwise, you've written off about 3 marks on the diploma. Seriously, there will be a permutation with repetition. I don't know if there'll be a pathway. There will be a permutation with repetition. Okay, and one of the questions was once this: just how many? So try this. How many arrangements of the letters in the word Peter? Seriously, I'm not centering you out. It really was. How many arrangements of the letters in the word Peter? P-E-T-E-R. Okay, how many arrangements are there? Two-thirds of the province got it wrong, right? So how many arrangements are there of the letters in the word Peter? Congratulations, you're one of the 2/3. Who wants to be in the 1/3? What's the answer? P-E-T-E-R. How many letters in Peter? Okay. Don't embarrass yourself on the real thing. So there will be I guarantee 99% sure there will be a permutation with repetition. It may be numeric response, right? What are you going to get? It's either 120 or 60. I don't think you get too many other answers. And that's the problem, right? There's not too many other ways of writing this to get different answers, right? If I start repeating more letters, then it's pretty easy to write a multiple choice, right? Because you repeat, twos, let's say it was like Peterson or something, and we spelled it S-E-N, or, whoops. Well, now there's 3 repeating letters, but, I'd like to have, like, let's say it's repeater, R-E. Okay, so now we got 3 E's and 2 R's, right? So that makes, it's like, oh, they don't see that there are 2 R's or something, or they think there's 2 E's instead of 3 E's. It's a lot easier to come up with answers for that, right? Because there's a lot more mistakes that you can make, other than just the one of saying, oh, 120. So yeah, some of the questions are that easy, but not